We talked about these types of systems last class or last video, and we worked 2 classes on them. Now we're solving similar, they're exact same problems, except these systems we're going to solve algebraically, which means we're not going to take a look at the graph. We're just going to figure out where they would intersect on a graph without actually graphing them. So we know our answer is going to look something like this. We're going to fill this in with the proper x and y value. And the way we're going to do that is using something called elimination. Now, you've learned that in algebra, what you do to one side, you do to the other. That we can kind of extend that here by doing something by adding equations to each other. Something you may not have done before. But look at these. This one is a very easy type of problem. And we're going to add these equations together. And what we do is we're going to add straight down or combine like terms. So we add 2x to negative 2x and we get 0x. We add 3y to 5y and we get 8y. So I added these together. My equal sign comes down and then I add 11 to 13 and I get 24. Now notice 0x is just 0. So it's gone. And what I've done is I've eliminated x. And that is why this is called the elimination method. You can't solve for 2 variables at the same time. So if you eliminate one of them, you'll be able to solve for the other variable. Simply, I have 8y equals 24. I'm going to divide each side by 8. And I get y equals 3. So that tells me that the y value is 3. So I'm going to write that there. And now what I got to do is figure out what the x value is. Well, the x value I can find by substituting 3 into either one of the equations. I'm going to pick the top one because that one doesn't have a negative, so I think it's easier to work with. So 2x plus 3 times 3 equals 11. So I rewrote the top equation, but instead of y, I replaced that with 3. So I got 2x plus 9 equals 11. Subtract 9 from each side. I get 2x equals 2. Divide each side by 2. So I get x equals 1. So I'm going to take that. I'm going to go back up here. A little faster, please. And I'm going to write 1 here. So your answer, again, all your answers should be in this form. 1, 3. So you can do all this work. You tell us what x equals and what y equals, but make sure your final answer looks like this and a coordinate pair. So let's move on. We're going to do a couple examples today. Now this one gets a little difficult. So we're going to progress into maybe like 3-4 stages of problems. This one is a little more difficult because if we add them together, they won't eliminate. The reason they eliminated back on the first one was because the 2x and the negative 2x were opposite signs. So what we need to do now is make it so that they're opposite signs. The way you do that is you multiply an equation by something. I'm going to multiply the second equation by negative 1. And when I do that, I got to multiply everything by it. The entire equation gets multiplied by negative 1. So what I'm going to do is I'm going to rewrite the first equation because I'm not going to do anything to that one. And then I'm going to multiply the second equation by negative 1. So I get negative 4x minus 3y equals positive 9. Now I'm going to add my equations together. You can do this because I know that 4x plus negative 4x is 0. So I'm just going to eliminate it and I'm going to cross it out. So now negative 9 plus negative 3 is negative 12. Y equals negative 21 plus 9 is negative 12. Divide each side by negative 12. And I get 1. So when I answer this problem, I know part of my answer is 1. And I put it there because that's the y value. So now let's go back and solve for x. I'm going to go back up to the first equation and write 4x minus 9 times 1 equals negative 21. So 4x minus 9 equals negative 21. Add 9 to both sides. 4x equals negative 12. Divide each side by 4. And I get x equals negative 3. So I'm going to put negative 3 up here, and we're going to box it or circle it or some way to show that that is the final answer. So if I plugged in negative 3 for x and 1 for y, it would solve both of these equations, not just one. All right, so let's move on. We're not going to do every problem in this package. Some of them I'd like you to do at home, on your own. But the next one we will do. So let's take a look at the next progression. None of our numbers are the same. So we started where they were the opposite. Then they were the same, so we made one negative. Now none of them are the same, but we can make them the same by multiplying the equations by something. And what you want to notice is that 6 is a multiple of 2. So if I multiply 2 by 3, that'll give me 6. But I don't want 6. I want negative 6. So I'm going to multiply by negative 3. So I'm going to rewrite the first equation. And that's only because I decided to multiply the second equation by something. So I'm going to leave the first equation alone. And now when I multiply the second equation, I get negative 3 times 2x is negative 6x, which is what I want. I get negative 3 times 3 is negative 9y. And negative 3 times 5 is negative 15. When I add these together, they go away. So remember, I'm adding my equations together. Always adding. So that's why I want opposite signs. Now I add 5y to negative 9y, and I get negative 4y. And 19 plus negative 15 is 4. Divide each side by negative 4. And that gives me negative 1. So my answer, I'm going to put negative 1 in the y. You could sometimes solve for x. Just happens that we eliminated y this time. Or sorry, we eliminated x and we solved for y. If you end up solving for x first, make sure you write that in the appropriate position. So now I'm going to go back. I am going to pick, let's pick the second equation. We picked the first equation last time. So I get 2x plus 3 times negative 1 equals 5. And now I have 2x minus 3 equals 5. Add 3 to both sides. I get 2x equals 8. Really easy. So x equals 4. This is an equal sign, not a negative. That made it worse. So we know that x is 4. So my final answer is the coordinate pair for negative 1. All right, so that is our third progression. We have one more progression to go. This one is very similar. I'm not going to do this problem. You can try it at home. But just a hint, the beginning of the problem is going to be multiplying the second equation by 5. That's going to give us a negative 10, which will eliminate with the positive 10 when I add these together. So let's actually, for the sake of time, so this isn't too long, let's look at our fourth progression. This is the toughest type of problem. Notice I've got 2 and 9. 9 is not a multiple of 2. And I have 8 and 3, and 8 is not a multiple of 3. So in this case, I need to multiply each equation by something. So let's decide to eliminate the x's. Let's eliminate these somehow. What I got to do is find the least common multiple of 9 and 2. That is going to be 18. So to get to 18, I'm going to multiply the top equation by 2 and the bottom equation by 9. But if I multiply the bottom equation by 9, I'm going to get 18. But I actually want to get negative 18. So I'm going to multiply by negative 9. So my top equation, I multiply by 2. And if I rewrite that, I get 18x minus 16y equals 8. Now I'm going to rewrite the bottom equation after multiplying by negative 9. So I get negative 18x. Negative 9 times negative 3y is positive 27y. And negative 9 times negative 4 is 36. Add the negative 18 to the positive 18 and it eliminates. Gone. Negative 16 plus 27 is that right? Yeah, 11. So it's like 27 minus 16. 11y, and 36 plus 8 is 44. Divide each side by 11. and I get 4. So my answer is something, comma 4. So again, we found what y is, so I'm going to put it in the second spot. And let's go back up and solve. Now what I would do is use one of the original equations. It's going to have smaller numbers. I would choose this one because it has smaller numbers, 2, 3, and 4. So, but the top one will work also. So 2x minus 3, sorry, not y. We're replacing y with 4 equals negative 4. So I get 2x minus 12 equals negative 4. Add 12 to both sides. So I get 2x, I should be adding 12. 2x equals 8. Divide each side by 2, and I get x equals 4. So I get 0.44. And that's it. So we take a look at the next one, and this is the same type of problem. I'm not going to do this one. You could try it at home, but one way to do it is to multiply. If I look to eliminate the y's this time, because that's always a possibility, I'm going to multiply the top equation by 3 and the bottom equation by negative 2. So you can try that one at home. Let's just do 2 more quick ones. The point of these is that you don't always get an answer. So let's talk about that. We remember there's 2 special cases. There are parallel lines which have no solution, and then 2 that are the same line, which is an infinite number of solutions. So I'm going to start this one by multiplying the second equation by 6. So I get negative 18x plus 6y equals 24. I just recopied the first equation. Now when I multiply the second equation by 6, I get 18x minus 6y equals negative 12. And look what happens. I get eliminated, another elimination. So on the left side I have 0. On the right side I get 12. Well, 0 does not equal 12. So this is a case where there is no solution. And if graphically, it would be parallel lines. So if you get something that's not true, this is false. 0 does not equal 12, it's no solution. And finally, let's take a look at the last case. I'm sure you can guess what this one's going to be. What I'm going to do here is eliminate the x's. Now, 9 and 6, the least common multiple is 18. So I'm going to multiply the top equation by 2, the bottom equation by negative 3, because I want to get opposite signs. So for the top equation, I get 18x minus 30y equals 48. And if I multiply the bottom equation by negative 3, I get negative 18x plus 30y equals negative 48. So now when I look here, look at this. Elimination, elimination, all 3 eliminate. So on the left side I have 0, on the right side I have 0. Well, 0 equals 0 is clearly true. So the special case for a true statement is infinite solutions. And that's it. So what we learned today is that you solve a system of equations using elimination method by adding the equations together. Sometimes you need to multiply one or both equations so that you get 2 numbers that are opposite that will eliminate. Solve for one, plug in, solve for the other. If you ever get if the variables go away and you get 0 equals a number other than 0, then you're going to have no solutions. But if all the variables and numbers eliminate on both sides, you get 0 equals 0, you're going to have infinite solutions. All right, so next class we're going to revisit the word problems and we're going to start solving those using the elimination method and comparing our answers to what we graphed. All right, that's it for today. See you in class.